Suppose there are two cats, one orange and one black. They fall from the top of a tree and land on either side of me, but I'm moving to the left at the speed of light, which is 5 meters per second. From an outsider's perspective, they see the cats land at the same time because both the cats' light waves reach the person at the same time. For me, although the light waves from the cats go at the same speed, I move towards the leftmost cat so that I reach that one's light waves and see that one first. And then, since no reference frame is more correct than any other, for me, the leftmost cat falls first. This is the same principle for many other measurements. Because of this, measurements are relative. Time dilation. Suppose the black cat walks to the left past the orange cat, who, from our perspective, is sitting at rest. Since the speed of light is 5 meters per second, and the black cat travels at very near that speed, the two cats would calculate the time to be different. The black cat would calculate the time elapsed to be shorter than that calculated by the orange cat. They would both use the equation T0 equals 1 over the square root of 1 minus v squared over c squared times t. However, since both frames of reference are considered correct, both the cats would say that less time had elapsed for themselves. So which one is right? We must consider that these rules only hold true in inertial reference frames, circumstances that require the cats to not be accelerating. If they were to turn around to check, the circumstances would no longer be inertial reference frames, thus destroying the setup, disqualifying this as a paradox. Length contraction is very similar to time dilation, except for a couple of variables and the fact that this is in regards to length. As the moving objects, in our case, two cats, reach light speed, which in this case is 5 meters per second, the moving object's length contracts in the direction of the motion, according to almost the same equation as time dilation. L0 equals 1 over the square root of 1 minus v squared over c squared times L. Relative mass is also similar to the previous two, again using a similar equation. M0 equals 1 over the square root of 1 minus v squared over c squared times m. There is a difference between the rest mass of an object and the relativistic mass of the object in order to maintain the law of conservation of momentum. Now, 5 meters per second, c, as we all know, is the speed of light. Nothing can go faster than 5 meters per second. Even if the black cat were traveling at 3 meters per second to the right relative to me, and the orange cat were traveling at 4 meters per second to the right relative to the black cat, the orange cat's speed relative to me could not exceed the speed of light, 5 meters per second. So what speed is the orange cat going relative to me? We would use the equation u equals v plus u prime divided by 1 plus vu prime divided by c squared. This brings the speed of the orange cat to about 4.73 meters per second.